Hi, here's a quick look at a Wolfram demonstration of the Gram-Schmidt process in 3 dimensions in R3. So after you download the player, the Wolfram player, a little application on your computer or on your iOS device, then you download the file, the demonstration file. It has a suffix of .cdf. So this is a .cdf file. I opened it up in the Wolfram player on my computer, and it shows me 3 vectors in R3. These 3 vectors are U1 is 5, 1, 0, U2 is 4, negative 1, 1, and U3 is 4, 5, 5. Now these are linearly independent, so this is a basis in R3, but we want to transform it using Gram-Schmidt into an orthogonal basis for R3, and then we want to cut them down to size. Multiply each one by the reciprocal of its magnitude so we can get them all to be length 1. So then we'll have an orthonormal basis. And so in this demonstration, you can click through the steps up here on these numbers. So we are in step 1, which is nothing has happened. We haven't done anything yet. So if you click on step 2, that's actually the first step of the Gram-Schmidt process. So step 1 is to get a new vector v1, and v1 is always just equal to u1. So that's what it says up here, v1 equals u1. So it's the vector 5, 1, 0. And down here we can see it's green. So our new vectors are going to be green. The old vectors are blue. So our first new vector is just our first old vector. And then you can click to the next step and see how to get v2. And up here is the equation, or the representation of v2. v2 is the old vector u2 minus the projection of u2 onto v1. And that's the vector 9 over 26, negative 45 over 26, 1. So keep clicking. You'll see all the steps. The final step here is where the green vectors, they weren't length 1, and so now they've been sort of cut down to size. Each vector has been divided by its length. So v2 becomes q2, and q2 is a unit vector going in the same direction as v2. So you'll get all these unit vectors. And the last step is just telling you exactly what the final basis is. Now, if you want to change the vectors, click on this little triangle next to change the vectors, and you can change each of the components of each of the vectors. And down below, under things to try, just hover over these things. So you can resize the image. If you hover over it, it'll tell you how to do that. You can rotate and zoom in 3D. So hover over that and it tells you basically you just drag it, rotate it like that. If you hover over slider zoom, it'll tell you how to get the slider that you can use to zoom in and out. And then gamepad controls control the demonstration with a gamepad or other human interface. So I don't have one of those. And then automatic animation. That's this little plus sign in the upper right corner. If you click on that, it opens up a couple of options, and you can click on auto run at the very bottom. It might go kind of quickly, but you can control the speed. So play around with this. Look at a couple different sets of vectors to see what they look like and how to transform the set into an orthonormal set. And also, I encourage you to check out other Wolfram demonstrations. It has quite a few, and you can download the source code if you're interested in making your own demonstrations. All right, so I will allow you to play around with it, and see if it helps you understand the process in 3 dimensions. And I'll see you in some other video.